Hey, we continue doing first trigonometry, and this trigonometry with compound shapes, part 2. Make sure you watch all 2 previous videos that were dedicated to complicated and I must say the hardest problems for A star or 9 score actually, for higher math, GCSE and IGCSE extended. I want to give a shout out to new guys. Thank you. Thank you, newcomers. So you're welcome joining us. And let's get started. All right, so we want to consider problem 3. It's right there. So what the problem 3 tells us. This sort of building, there are 2 points of observations and we have 2 basically angles of elevations. So you need to answer all those questions. Pause the video, try to do it by your own, and let's get started. Okay, so here's actually, we have C as the top of the building, and this is the height. This is the height. So here is the ground level. So we have 800 meters from B to the base, and we also have 2 angles of elevations from point A and point B to C. Okay, so let's assume there are 2 observers staying in point A and point B. All right, so first, we need to find the size of the angle ACB. So ACB, so it's right there. I mark it as X degrees. And we're going to start working out. Okay, so X degrees. Okay, so that's actually angle of X degrees. How to work it out? How to work it out? Is there any chance? Yeah, I think we can use just angles. So let's say that's 45 degrees. So here is the right angle right there. So we can use small triangle B. Let's set up the point D here. And we can use triangle B, C, and D as right angles. So that's 45 degrees. So we can figure out the first angle, which is simply also 45. So change the color, sorry. Let's take that color. It's good. So that angle is 45 degrees. Okay. Next triangle, 35 degrees, 90 degrees, and the whole angle ACD. So we know that, so we first establish angle BCD. It's 45 degrees. And also we can establish the angle ACD. So angle ACD is simply 10 degrees more because 35 is less than 45 by 10 degrees. So actually the top angle is going to be 10 degrees more. So that's 55. And actually we can figure out that angle X is simply 10 degrees. So angle X is simply 10 degrees. So that's what stays for angle ACB. So that's why the answer is right there. So 10 degrees. All right, so the next question. We have to find the distance from A to C, from A to C, and from B to C. So actually, let's mark them as D1 and D2. So this is D1 and this is D2. So that first distance and the second distance. So we need to figure out D1 and D2. Okay, so what we know about that? We're not given height, but we are given 800 meters and a small triangle BCD. So we can use triangle BCD. It's right angle. So we can figure out that 800 meters, and because 2 legs by, so 2 angles by 45, this triangle is isosceles, so we can say that those 2 legs are the same. So that's why the height, which is here, is also 800 meters. 800 meters. Wow, that's real tall building like skyscraper. Okay, so can we figure out D2? Of course we can figure out. So I would use let's say cosine rule, because D2 is hypotenuse, 800 meters, the bottom leg is adjacent leg, so we can write that 800 is going to be D2 times cos of 45 degrees. All right, so from where we can figure out that, so D2 is simply 800 over cos 45 degrees, and that's already a solution for the first unknown. Let's calculate that. So cosine 45 square root of 2 over 2, but we just use calculator and we calculate. So what I've got 1131. So to the nearest whole is going to be 1131. But if you like, we can round up to 2 decimal places. It's going to be 37 in the end. And meters. Okay, so we figure out the first unknown. It's right there. Okay, so what about D1? We also can figure out, because we found that the height is 800 meters well due to isosceles triangle, so we can use the big triangle ACD. So that's why from triangle ACD we can figure out that D1 in the same manner, but we don't know AB, right? So, but we know the height is 800 meters, and we know opposite, so this is the opposite leg for 35 degrees. So that's why in this case 800 opposite 35 angle degrees, and D1 is hypotenuse, we are going to use sine ratio, so we can work out that 800 is simply D1 times sine of 35 degrees. Okay, so that how it works. This is D1 sine 35, sorry, and D1 from there is simply 800 over sine 35, so D1 is 800 over sine 35. So from where we can simply say that, so in this one, in this case, 800 over sine 35. And what I've got the distance 1394 and 0.76 meters to 2 decimal places. All right, so we've got the second distance, actually the D1, but we did it in the second step. All right, so we've got 2 distances and we've done A and B. All right, find the height of the building out to the point C. So we've already found it. It's 800 meters due to isosceles triangle BCD. So we can say that BCD isosceles triangle. All right, so next one, use the given figure to show that. Oh, that's actually the end, because we also have the next problem, and in the next problem we want to figure out, let's go to the next one. So using observation from problem 3, derive the formula which will express the distance d between points, it's right there, AB, and so through the height of the building H, right there, and angles of elevations alpha and beta. Okay, so we need to derive the formula that connects d as the distance, and it's a subject in the formula for distance connected with height of the building with angles of elevation as well. Okay, so how to work it out? So guys, what we can use, I think we can use the big triangle, so hopefully in this case, so we need just to connect D and H, and that's it. Okay, let's try to do. So what do we have for that? So distance and height, age. All right. So what I actually can do, we have better angle and we don't have anything. So maybe let's set up some angle x right there, or not the angle x, but the side x right there. Yeah. So this is the distance between B and the bottom of the base of the building, or the bottom of the building. So that right there. So if we set up that x, so what we can do, we can express height through x through better as well. Okay, so what we're gonna do, h2x is going to be tangent angle better, right? Let's have a look. Opposite to adjacent in the small triangle. Okay, well done. The next one, if we consider D and X together, so the whole distance, so from point A to the base is going to be D plus X, right? Yeah, so this is D plus X, the distance. So one more time, D plus X. And from the big triangle, we also can connect H through the angle alpha using the tangent rule. All right, so that's going to be H2 D plus X is going to be tangent of alpha. Okay, so this is enough because this simultaneous equation, and let's have a look which variables we have. So I circled them. So we have H, that's what we intended to have. We have angle better, we have alpha, we have H here, and distance, that was actually crucial for us because D is going to be a subject in the formula. So we don't need to have X, right? So what we can do, we can express X from the first equation. So set up numbers for the equation and let's try to solve them as simultaneous one. Okay, not to solve, but actually use simultaneous principle in order to express variables that we need for. All right, so X is simply H over tangent better. I just swapped them, okay? So next one, we can plug there, but before plugging, I want to resolve crisscross. So H is going to be D plus X times tangent. So from where I can say that D plus X and times tangent of alpha. That's what we have, right? Yeah, we have that. So H is D plus X. So we can forget about this. So forget about equation 1 because we don't need this. And let's concentrate on the equation 2. I mean, maybe a bit in advance I said that forget. So we need to plug instead of X. So right there, we can plug this. And then we can forget about the first equation because we don't need X. All right, so let's plug it. And we'll have the following. So H is going to be equal to, set up there. So H is going to be equal to D plus H over 10 better times 10 alpha. Okay, so what we're going to do, we need to express D, and D is right there. So D is right there. So what we can do, we can simply say that, first of all, let's express the whole bracket here. So let's express the whole bracket here. So it's going to be H over tangent alpha. That what is going to be D plus H over tangent. That was tangent alpha, and this is tangent beta. Alright, so next we just eliminate h over tangent beta from both sides. So that's why we can express distance. So d is going to be equal to, so h over 10 alpha and minus h over 10 beta. So actually that almost done. However, I would like to factorize h because h is the common factor here. So finally, we will have that distance that we need to express. So d is going to be equal to h is a common factor. So in brackets we'll have 1 over 10 alpha. So minus 1 over 10 beta. All right, and closing brackets. So we've got the formula. Well, let me try to, I'm not sure, maybe it won't work. Yeah, I think so. Okay, so anyway, we expressed that, and that was the solution for the problem 3 that we had before. And the last formula, so d is expressed, so down here. And if we go back, you can see, guys, solution for all A, B, C items. So D, it was redundant because we don't have anything for that. So that was Daniel Dallas. I hope you understood how it works. So actually, before we use the basic principle and barely touch first trigonometry, so we use the basics. So however, in the second one, so we used basic trigonometry, however we arrived to simultaneous equations. All right, so that was first trigonometry. Up to your request, guys. Thank you for watching. Thanks for subscribing. I really appreciate that. And so it seems to me that I switch next to I think 2 sets. All right, see you later.